All right, so the next part here is about browser extensions, and browser extensions used to be ubiquitous. More than 10 years ago, back in the time of Windows XP, everybody had to have Flash in their browser, and sometimes they had Java, and then Microsoft made a competitor called Silverlight, and so you'd have these other languages in there processed by an extension in your browser. And but these things all went out of date and are pretty much gone, largely because of Apple. Flash was terrible for security, and it was Steve Jobs regarded Flash as being bad for the battery life too, so he refused to let the iPhone browser support Flash. So that meant when the iPhone became popular, all the iPhone users couldn't see those Flash videos, which were everywhere on the web, and that eventually caused Flash to just become extinct. People had to quit using Flash if they wanted iPhone users to see their stuff, and the iPhone became very popular, so you couldn't afford to just write off those iPhone users, and everybody said, this is kind of for the birds. And then they brought out HTML5, which would let you animate parts in a page natively in HTML, so you didn't need an extension. Back before HTML5, the only way to make like a good-looking cartoon or movie or anything was to use Flash. So these things are pretty much no longer used, although some people still use Java. But and all the data that went into these extensions could also be modified in burp and viewed. So if you had a casino playing some kind of like roulette wheel or something, it might be doing some of that on the client instead of on the server, and then you could cheat on the game and such. So it used to be Java applets, which still exist, although a lot of people don't enable them anymore, and Flash and Silverlight are pretty much extinct. But they all work about the same way. They compile code down to bytecode, which is machine-independent language, which then runs in a virtual machine. And all right, and they also use serialization, which we were talking about before with the ASP view state, where they have a bunch of data compressed into one blob of base64-looking stuff, and that includes a whole bunch of data in some kind of serialized object. And so Java is the technology that's worth understanding because it's still widely used, especially on mobile apps on Android. So Java applets run in a Java virtual machine, and they're serialized. You have this content type in the request called a Java serialized object, which comes down, and there is a burp plugin that will handle that data. So if you have the older kind that is not encrypted or anything, then it'll take it apart and you can see what's in there. The raw data is over here, this raw binary data that doesn't even print right with these squares, and it can be taken apart and then you see the contents on the right. So it's essentially the same thing as Microsoft's imitation, the ASP view state. And all right, so you have to unpack it with a serialization unpacker, and then you'll see the parameters inside there, and you may be able to modify them and find vulnerabilities like the other things we're saying. Yeah, Java servlets were like, that's right. Anyway, so let me talk about the case that really is used now, which is Android. And I'll probably be teaching the mobile device hacking class next semester, and then you can do this if you haven't. But I did a lot of bank apps, and in particular Bank of America. So you install the Bank of America Android app on an Android phone, or an emulator, which is what I used. Then you pull it down with ADB, and you get a copy of the app, and then you unpack it with Java APK tool. This can unpack the app so you can see the code. And here's the unpacked app. It has many folders called things like auth and bill pay, activities, enrollments. And you see some things are just changed into meaningless names like A and B and C, but other things are still readable like business credit card details activity, and it's .smali. Smali is bytecode. That is compiled Java. When you compile Java, it doesn't really change it very much. This is Java. You have a public integer function called perform login, and it takes a username and password, and the username and passwords are down here. And when you compile it, look, it's still completely readable. Perform login, string, parameter username, parameter password. This is something that many developers apparently do not understand. If you write code in C or C# or something and compile it, it becomes really hard to read. But if you write code in Java and compile it, you end up with something that is almost identical to the source code. You can still read the names of the methods, the names of the variables, and all that. It's actually easy to manually modify compiled Java code, and that's how you hack into Android apps. So you can just modify the Smali code. I went in the code and I found a place where it handled the credit card number, and I just changed the local variables from 3 up to 5 so I could take a variable and put the credit card number in there and stick it in the log. So I was able to add 2 pieces of code that would take the credit card number and put it in the log, and now you repack the app, you re-sign it, you reinstall it on your phone, and now when people put their credit card number in the app, it dumps it in the log. And you get the credit card number and the CVV. So I sent a lot of vulnerability reports to the major banks and all sorts of people for this. It turns out that a lot of the code is vulnerable to code modification. It's one of the OWASP top 10 vulnerabilities, and almost every app is vulnerable to this. Now, if you had an app that didn't obfuscate data at all, which some of them didn't, you'd just see everything right here. And this was Progressive, the Progressive Insurance app. Not obfuscated at all, just descriptive names for every folder and file and variable, so make it very easy to reverse engineer the app. ProGuard is a free obfuscator for Java code that comes with the Android Studio, free development environment from Google, and ProGuard tries to hide stuff by changing it to A, B, and C, but it doesn't change them all. What was the 3 and 5 representing from my example? I don't remember 3 and 5. Which slide are you talking about? 3 and 5? You remember which slide? I changed the 3 to a 5 in the bytecode. I did, because the way bytecode works is you specify up here how many local variables there are in this method. And if I was to reuse a local variable that was being used for another purpose, the app would crash. So what I did was change it from 3 to 5. So now, originally I could only use variables v0, v1, and v2. Those are the local registers you can use in the Java virtual machine. By changing this to 5, I made it possible for me to use v3 and v4, new variables that had never been used by any other part of this method. That's why I put this message in v3 and this one in v3. That's the trick. This is one of the tricks. So this is a way you can free up another variable, so my modified app will use a little more memory, but it will run. One thing about, by the way, modifying compiled code like this is if you make any mistake at all, it will just crash. You don't get error messages or anything. So it's a little touchy, and it's kind of like what we're doing in the exploit development class. We're going to be injecting shell code, and if you make any mistakes, it will just crash. It doesn't do anything to help you. So it's a little tricky. Yeah, that's what this was. This was just a way to free up a variable that I could use without crashing the app. So anyway, if you use the ProGuard obfuscator, the free one, it changes some of the methods to like A, B, and C, but it doesn't change them all, and a bunch of it still remains readable. So this free obfuscator is incredibly weak. And there are professional obfuscators that cost thousands of bucks that do a much better job. Scramble all the names and make it harder for a reverse engineer to figure out what's going on in your app. Remember, a similar thing happened on a PHP code accelerator engine. It forced a proprietary forum software change to an open source completely. Oh, it exposed the source code? Yeah, that's the thing. Good. Yep. Obfuscated malware on web pages is often obfuscated PHP or obfuscated JavaScript in similar ways. Anyway, so if you're going to have data on the client side, you shouldn't accept critical data like prices from the client. If you get what you should is just send up the product ID and look up the price on the server. If you must send important data to the client and back, then you should sign or encrypt it so that the user cannot modify it easily. And even if you do that, it might still be vulnerable to replay attacks or possible cryptographic attacks if there's some kind of weakness in the cryptography you're using. So It's a thing to be aware of. All client-side validation methods could be turned off or modified. You don't really know that they ran correctly. The only secure way to validate data is on the server. And of course, something you're going to hear every chapter until you're probably tired of hearing it, is you shouldn't take modified data that somebody has clearly modified with something like burp and just use it. You should take that as a clue that this person is hacking my app and I should stop servicing that person. I should block their IP, send up a log, freeze their account, something like that. I should take some kind of action since I've noticed that this data was not like if I limited the number of items to 5 and you sent me a request for 6, I know you cheated somehow. I shouldn't just ignore that. I should take that as a clue that you're an evil hacker and freeze the account, terminate the session, raise an alert, something like that, And it's too bad that so many people just modify data, clean it up, and use it anyway. That's just asking me to hack you. All right. So let's take a look at B in the Cahoots. Slide title has a typo. Oh, all right, I'll take a look at that after the Cahoots. While that's going on, I'm going to move this over here and see if I can spot the typo. Well, I don't see it. So you have to tell me which slide had a typo. Slide 51. Okay, let's see. Handling client-side data securely. Looks okay to me. Handling instead of... Oh, it does. You're right. Thank you for telling me. The L is missing. I didn't even see that. Good. Thank you. All right. So that's 16. I guess I'll give it a few more seconds. All right, I guess that's enough. All right, so which one of these is not compiled to bytecode? Well, the delay has risen to 10 seconds again. You can't win them all. Right, HTML is the only one of these that is not compiled down to bytecode and running some kind of virtual machine. Right, what should you do if you get data that violates your validation rules? Yeah, that's the thing. What people often do is sanitize it and use it, but what you really ought to do is realize you're being hacked and take some kind of action like terminating the session or freezing the account or something like that. All right. All right, how do you make data from the client trustworthy? All right, if you sign it, that's pretty good. If you have a good cryptographic signature, that's very hard to forge. So that's the best answer. You could argue there's no perfect way, but signing it is very good. Proper message authentication code can't be forged. That's the whole point of them. So that's an option. All right, Eileen, a new winner. And Woot, I got a record of who that is. And J is, I think, Judy. I think JC was Jordan. All right. So,